Hey everybody, welcome to 6.3. Today we're going to be talking about tests that we can use to show that a shape is an actual parallelogram. This is similar to the last section. The difference is this time you're going to be given a shape with some information and you have to tell me is it a parallelogram or not and why. Whereas in the last section we learned where we were told that they were parallelograms and we used the fact that we knew it was a parallelogram to solve for missing sides or in some kind of application. So this is kind of the backwards version of it. So I'm just going to start off with a basic example and then we'll kind of build from there. So here I have a quadrilateral, okay, 4 sides, and it says, is this shape a parallelogram and explain? And let's say that I give you the measurements are 12 centimeters, here and here, and then 5 centimeters on these 2 sides. So you have to think back to what we knew about parallelograms. So there's going to be basically a couple different tests that we could use to determine if it is or isn't. And the first one is that we know that opposite sides of a parallelogram are congruent. Okay, so there's a first test. We also know that the opposite angles are congruent. Okay, so there's a second test we could use. The third test could be that the diagonals bisect each other. Okay, so if we see something where the diagonals bisect each other, we know it's a parallelogram. And then the last one's a little bit different. The last one is if one pair of opposite sides they are parallel and congruent. So it's got 2 parts to it. And then obviously our more obvious one is if both pairs of opposite sides are parallel, okay, that's by definition a parallelogram. So there's a total of 5 technically, but the 4 that we're going to focus on are these here in red. So when you're given a shape, you need to see if it applies to one of these 4 rules, or 5 if you want to talk about the parallel sides, and then go from there. So if we look at this shape here, what's the only thing we know? Well, we don't know anything about diagonals, we don't know anything about angles, we have nothing marked parallel, so we can't use this. So we have to look at the first rule. Well, the first rule says opposite sides are congruent. So we need to look, are the opposite sides congruent? Yes, they are. Okay, so here's a pair, they're the same. And then here's a pair that are the same. So is this a parallelogram? Yes. And then your explanation would be that the opposite sides are congruent. Done. All right, so they don't take a lot of explanation to go with them, but you have to make sure that it applies to one of the 4. And notice that we have to have both pairs of opposite sides, not just one pair. Very important. All right, so let's look at another example. Let's see here. Let's say I give you another shape, another 4-sided figure. Okay, so there's this one. And maybe I tell you that this is 85 degrees, obviously not drawn to scale. This is 85 degrees, and then we know that this side and this side are congruent. So I want to know, in this example, so example 2, is this quadrilateral a parallelogram? And explain. Okay, so let's look at our 4 rules. Hopefully you wrote those down. So we need to see if things apply. So we know that a pair of opposite angles are the same. Okay, so we know that these match. However, the issue with this is that we only have one pair. So we have one pair of congruent angles. But is that enough? Well, if we look back to our rules, we have to have both pairs. So we don't know anything about that, so that's not enough. And then we know that one pair of opposite sides are the same. Okay, so one pair of sides are congruent. But we have to have the other pair of sides. So in this case, do we have enough information? No, we don't. Okay, so yes, this is helpful, but we were needing the extra information. So you would say, not a parallelogram. And then the reason here would be we don't have enough information, okay, or something like that. So not enough info, or you could say it doesn't fit any of the tests. okay, because we had 4 tests to pick from. So either of those explanations would be good. We need more information. We need either another set of angles or another set of sides that are the same. All right, so this is really helpful because if you were ever to take something, for example, a piece of paper, maybe you were designing something for a project or for a poster or something, and you needed it to be a parallelogram, so you wanted it to be tilted or anything like that, and you weren't sure, or if you didn't have any special tools to figure it out, all you'd have to do is make sure that one of these tests applies, maybe measure the opposite sides, or measure, if you had something to measure the angles on a computer program, measure the opposite angles and make sure those are the same, and then that would make sure automatically that they would be a parallelogram. All right, so you don't have to know much, but just something about the sides, the angles, the bisectors. All right. So now we're going to use these rules in a little bit more of a solving setting. So, for example, if I give you this picture, okay, and we're going to label this, let's see, JFGH. So this is J, F, G, and H. And then we're going to also draw diagonals in here from F to H, and then from J to G. And where those diagonals intersect is going to be at point K. And so we'll have this as example 3. And in this problem, I'm going to tell you that FK is equal to 3x minus 1. Okay. And KG is equal to 4y plus 3. And JK is equal to 6y minus 2. And let's see, KH is equal to 2x plus 3. And they're going to ask you to find x, or solve for x, so that, find x and y, I guess I should say, so that this shape is a parallelogram. All right, so anytime they give you this information, I would go ahead and label your picture. So from F to K, that's part of the diagonal, so that's that 3x minus 1. From K to G is another part of a diagonal, that's the 4y plus 3. J to K is the diagonal here, 6y minus 2, and then K to H is that 2x plus 3. So right now, they don't tell us that this is a parallelogram. All they tell us is it's a 4-sided figure, and here's some information. So what would I have to do in order to make this a parallelogram? Well, going back to our 4 tests, remember, we can look at those 4 things and we can see which one would be helpful. Well, we don't have any side lengths, we don't have any angles, but we do have a rule that says diagonals in a parallelogram bisect each other. So that would be a good test to use. So I'm going to write this down. Diagonals in a parallelogram bisect each other. So if I know that these are going to have to bisect each other, that means that from F to K, it's going to have to be the same as from K to H. And the same thing applies from J to K, will have to be the same as K to G. So all I have to do is set up an equation. So I'm going to have to make FK equal to KH. So FK will have to, FK will have to be equal to KH. And so I just have to plug in what I know. So FK was 3x minus 1, and KH was 2x plus 3. And now I can solve this for x, and that will make those diagonals congruent to each other. So if I subtract 2x over, I get 1x minus 1 equals 3. Then I can add 1 to the other side and get x is equal to 4. So by x being 4, I've now made these bisected, okay, and then I have to do the same thing for the other diagonal, because remember the rule says diagonals bisect each other, so they both have to be equal. So now I can say 6y minus 2 has to equal that 4y plus 3. So JK has to be the same as KG, and then I can solve. So subtract 4y to the other side, and I get 2y minus 2 equals 3. Then I can add 2 to the other side and get 2y equals 5. And then last but not least, divide by 2, and I get y equals 5 halves, or this is the same as 2.5. So by setting up these 2 equations, this is just like what we did in section 2, but here I'm forcing it to be a parallelogram by applying one of the tests that we talk about, one of the 4 tests. So I made the diagonals equal to each other so that this was now going to be a parallelogram. Right? So it's going to be a lot of setting things equal to each other, which is kind of nice when you set up your equations. and then you should be able to go from there. So I want you guys to try this example, and then we should be able to kind of finish up pretty quickly with this section. So let's say I give you a parallelogram. I'm going to turn it a little bit. Let's say I have it looking like that. So this is example 4. And they want you to solve for x and y so that the shape is a parallelogram. Okay. And in this shape, let's say I tell you this is 56 degrees. Let's say this right here is 5y minus 26. This angle here is 7x. And this angle here is 4y plus 4. So I want you guys to go ahead and figure out how you would solve for x and y so that this shape is a parallelogram, because right now it's not, but we can make it a parallelogram by setting up equations a certain way. So solve for x and y, answer the question, and then you should be good to go. Okay, so when you set this up, you should have said that you were using the rule that opposite angles are congruent. So opposite angles are congruent in a parallelogram. So that means that 56 has to go across to 2x. So you should have said that 56 is equal to 7x and then solved. Okay, so you guys can finish that. And then you should also be able to say that these angles that are opposite are the same. So your second equation should have been 5y minus 26 has to be equal to 4y plus 4. So check on your paper and make sure you set those equations up the same. And then if you haven't solved, make sure you finish solving those and get the same answers. Okay. But really you're just solving for y, solving for x, and then you'd be done. So they don't care about the measures. They just want to know what would x and y have to be. All right. We're going to talk about one more example, then we're going to wrap up this section. This next section is if they give you a shape on a grid. Okay, so they might say, let's see, so this will be example, I think 5. Yep, example 5. So it'll say graph quadrilateral, let's see, K, L, M, N. If K is the ordered pair 2, 3, L is the ordered pair 8, 4, sorry, I looked at my book, M is the ordered pair 7, negative 2, and N is the ordered pair 1, negative 3. And then it says determine if KLMN is a parallelogram. Okay, so first, let's graph it. Okay, so I'm going to pull on my grid here. So if we graph these 4 ordered pairs, we go to 2, 3. There's K. Always make sure you label your points. Let's see, 8, 4. 1, 2, 3, 4. So there's L. 7, negative 2. So that's going to be M. And then 1, negative 3. So there's N. So then we can go ahead and connect those 4 points. Okay, just like that. Nice and neat. If you need graph paper, you're always welcome to borrow some from class. So we have this, and what do we need to know if we want it to be a parallelogram? Well, remember, we talked about our 4 main rules. Opposite sides have to be the same, opposite angles have to be the same, diagonals have to bisect each other, or we have to have a pair of sides that are congruent and parallel. Okay, so the thing with this is, we don't know any angle measures, so that can't help us. We don't have any diagonals, so that probably isn't very helpful. We can find the side lengths. Okay, we could use the distance formula 4 times in order to show that these are the same. However, distance formula 4 times takes a long time. So remember, by definition, the word parallelogram means that opposite sides are parallel. So if we can show that these opposite sides are parallel to each other, then we know it's a parallelogram. Well, what do we need to know in order for something to be parallel? Well, we know that parallel, in general, means that the slopes are equal. Okay, so they're never going to touch. Okay, so they will never touch. So all we have to do is look for the slopes. Well, slope, remember, is rise over run. That's something we should know at this point. So I could find the slope of every single side and see if the opposite ones are the same. So let's find from K to L. So if I go from K up to L, I go up 1, so rise over run. So up 1 and then over 1, 2, 3, 4, 5, 6. So 1/6. So there's the slope of the first one. Okay, so I'm finding all my slopes. Then I can go from, what's the opposite one here? From N to M. Okay, so I'm just going down to this one because it's a cross. So from n, I'm going to go up 1, and then over how many to m? 1, 2, 3, 4, 5, 6. So over 6. Okay, so those slopes are the same. That's good. And then I can do the same thing for the other one. So let's find from m to l. So ml's slope, if I start at m and go rise, so I'm going to go up 1, 2, 3, 4, 5, 6. I'm going to go up 6 and over 1. Okay, and then from n to k, if I find that slope, I'm going to go up 1, 2, 3, 4, 5, 6, and then over to the right 1. So these are both the same slopes. So if the opposite pairs are the same slopes, then I can say they are parallel. Okay, so those are parallel, and then my other sides are parallel. I'll put 2 arrows on them. And remember, parallelograms by definition have opposite sides that are parallel. So if the opposite sides are parallel, then yes, it is a parallelogram. So there's more than one way to show this. Okay, slope would be the easiest on a graph because you can just count up and over, but you can always use distance formula, or you can use a combination of distance formula and slope to apply to that fourth test that we talked about. So whatever you find is easiest, I would go with slope, but you have options if you prefer one method over another. All right, so if you have any questions over this section, let me know when you come to class. Otherwise, that's it for today. Thanks for listening.